Welcome to this note. You can think of this session as a masterclass on the invisible backbone of modern digital infrastructure. Whether you're a startup founder, a cloud architect, or maybe you're just looking to skyrocket your freelance career in IT, mastering the systems that actually keep the internet running, well, that's your gateway to immense value creation. So let's just dive right in.
Hooking your network together can honestly feel like total chaos. You've got Cisco routers, Windows servers, HP printers, and even automated UPS systems all in the mix. So how do they all communicate seamlessly? Well, think of what we're learning today as the ultimate universal remote control. It's a protocol created way back in 1988 that, amazingly, still manages to be the absolute essential tool for keeping our global digital economy from just completely crashing.
That universal remote, it's called SNMP, or the Simple Network Management Protocol. It operates at the application layer and uses UDP. Now, UDP is a transmission method that prioritizes lightning-fast speed over the guaranteed delivery you'd get with TCP. And its adoption scale? It's literally staggering. Almost every single managed network device on the market today ships with SNMP built right in. It is the absolute gold standard for gathering performance metrics and detecting faults across the board.
All right, moving into Section 1, Architecture. Specifically, managers and agents. To really understand SNMP, we first need to look at the core relationship that makes the entire protocol function. This relationship relies on a very strict manager-agent model. It's kind of like a classic boss and employee dynamic. On one side, we have the Network Management System, or NMS. This is the boss. It runs the monitoring software, provides the dashboards, and handles the alerts. And on the other side, the agents. These are the local software processes, basically the employees, living right inside your routers, your switches, and your servers. The boss asks for reports, and the employees provide the data. Simple as that.
So the really crucial point here is how they actually talk to each other without getting their wires crossed. They use specific communication channels or ports. The manager sends its requests out using UDP port 161. But when the agent needs to suddenly raise its hand, say to report a critical failure, it reaches back out to the manager on UDP port 162. It's really a beautifully simple dual-lane highway.
Okay, Section 2, Decoding the Code, MIBs and OIDs. We know the who, so now let's look at the what. How does the manager actually know what kind of data the agent has to offer? This brings us to the MIB, or the Management Information Base. Since there are literally tens of thousands of different tech products out there, your central manager just can't natively understand all of them. So the manufacturers supply a MIB file. It's essentially a massive data dictionary that you load right into your manager. It translates all that raw, confusing device data into human-readable metrics like CPU temperature or fan speed. Now, inside that MIB, the data is organized using an object identifier, which is a huge string of numbers, like 1.3.6.1.1.4.1.2682.1. Super intimidating, right? When you first see this out in a production environment, it looks like absolute gibberish. But don't worry, I promise it's highly logical once you break it down.
You just have to think of an OID exactly like a library sorting system, or even a file path on your computer. It reads left to right, it starts at a universal root node, then drills down into the specific organization, then the vendor, like Cisco or Microsoft, and finally arrives at the exact metric you want, like interface bandwidth. Once you actually know the system, that scary random number becomes a highly precise navigable address.
Moving on to Section 3, Actionable Verbs, how SNMP communicates. Let's shift from the data structures to the how. What are the actual actionable verbs that bring this network telemetry to life?
There are 3 fundamental operations you absolutely must know. First up is the GET request. This is just the manager actively polling the agent, basically asking, hey, what's your current memory usage? Then there's the SET request. Now this one is incredibly powerful. It allows the manager to remotely change a configuration, like totally disabling a compromised switch port. And finally, we have the TRAP. This is an unsolicited alert sent straight from the agent to the manager. The agent doesn't sit around waiting to be asked. It just shouts, hey, we have a problem.
And let's really ground this in reality, because traps are where the massive real-world business value lives. These aren't just minor IT notifications. We're talking about business-saving alarms. A link-down trap, that tells you a core fiber cable just got cut. A disk-full trap can literally prevent an entire e-commerce database from crashing right in the middle of Black Friday. And an authentication failure trap, that could very well be your first warning that a hacker is actively trying to brute force their way into your infrastructure.
Catching these things in real time saves companies millions of dollars. All right, Section 4, Security Evolution, from SNMP v1 to SNMP 3. Because, as you can imagine, managing an entire network remotely is a massive security risk if it's not handled correctly.
Historically, SNMP was, well, deeply insecure. Versions 1 and 2C used something called community strings, which are basically just passwords to authenticate. But the fatal flaw here is that they sent these passwords in absolute plain text over the network. Anyone with a basic packet sniffer could just steal your credentials. Now, version 2C was still vital because it introduced 64-bit counters. Why does that matter? Well, on modern high-speed 1 gigabit links, an old 32-bit counter would actually wrap around and reset in just 34 seconds, totally destroying your data accuracy. But even with that performance upgrade, V2C was still inherently unsafe.
Enter SNMP version 3. This is the modern production standard, and if you're building or consulting for enterprise networks today, this is absolutely what you implement. SNMP v3 completely replaces those risky plaintext strings with the user-based security model. It authenticates users with cryptographic hashes, and crucially, it encrypts the actual data payloads using AES. It also introduces view-based access control, which means you can restrict exactly which parts of the network specific users are even allowed to see or manage. It's a total game changer.
Which brings us to Section 5, the future of network operations. Now, why should you, as a forward-thinking professional, care deeply about mastering this? Let's talk about the future, your career, and the real monetization potential here.
The business value of deploying comprehensive SNMP monitoring is frankly astronomical. We're talking about proactive capacity planning, knowing for a fact that you need to buy a new server 3 months before the old one actually maxes out. It gives you centralized security visibility by feeding traps directly into major CM systems like Splunk or Elastic. If you can walk into a business, audit their infrastructure, and deploy a system that prevents just one major outage, you've easily justified a massive consulting fee right then and there.
And this builds directly into some incredibly high-income career tracks, whether you're aiming for the Security Operations Center, designing cloud architecture, or stepping right into the future with AI-driven operations, or AOps. You see, artificial intelligence models require massive amounts of accurate, real-time data to learn from. SNMP telemetry is exactly the raw fuel that feeds those AI models running the autonomous, self-healing networks of tomorrow. To wrap up our Know today, I really want to leave you with this clear thought from our sources. SNMP is the foundation of modern network monitoring and management. At a professional level, it really isn't just some legacy protocol. It is the absolute discipline of digital infrastructure governance. It's exactly how you observe, secure, and automate the digital world around us. So the final question I have for you is this. Are you ready to build, monitor, and secure the autonomous digital infrastructure of tomorrow? Take this knowledge, start mapping out the devices in your own lab, explore those monitoring tools, and just start building solutions. The opportunities in the digital economy are out there waiting for those who truly understand how all the pieces connect. Thanks so much for joining this note, and keep building.